Hey guys, welcome back to AlgoYogi. We are doing binary search series and our next problem in the list is Koko eating bananas. So let's go to LeetCode. So Koko loves to eat bananas. Koko is a monkey here, just to clear that up. There are n piles of bananas. The ith pile has basically piles ith bananas. The guards have gone and will come back in h hours. So guards have gone out of the garden, not the garden or orchards or whatsoever, and now they'll come back after h hours. So Koko has the chance to eat bananas. So Koko can decide her bananas per hour eating speed, which is represented by this integer, this variable k, and each hour she chooses some pile of bananas. So basically these are the piles over here. These are the piles. First pile has 3 bananas, 6 bananas, 7 and 11. Now each hour she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. So basically, if let's say we were choosing this k, by the way, we have to return this minimum integer k, which represents this eating speed of Koko. Koko likes to eat slowly but still wants to finish all the bananas in the till the time guards are back. So she wants to choose this minimum eating speed so that by the time guards come back, which will be after h hours, she wants to finish all the bananas. And rules we just read here is that she can choose one pile at a time and she will finish all the bananas before moving to the next pile. But here's the thing. Let's say we were choosing k as 4, the eating speed as 4. We know that even if in the first hour, basically this with the eating speed of 4, she finishes basically 3, even less than an hour, right? Because her eating speed per hour is 4, so maybe she finishes that maybe 45. If we divide 60 by 4, then it will be basically 15. Yes, 15. So basically you will have 15 more minutes left, but she will rest here after that. She's not moving to the next pile to eat another, Okay, so let's try to understand the problem on paper. So I'm going to switch the view here. So here you see we have the pile that's from the first example. Now this pile has these different number of bananas, right? First pile has 3 bananas, next pile has 6, and then 7 and 11, and we have maximum basically 8 number of hours, and we need to finish all of these bananas in 8 hours before the guard come back. So we need to choose this k. We need to choose k, and k has to be basically minimum because Koko wants to enjoy her bananas. She just doesn't want to shove down these bananas before, and then she will choose a pile and spend at least 1 hour there. Okay, why? Because maximum bananas in 1 hour she can eat are basically the bananas on that pile, because even if she finishes all the bananas, if we choose this k really high, even then she wouldn't switch to another pile because she will. That's the rule in the basically in the description of the problem. So how about we just choose our k? So let's say we choose our k, and k will be basically between, k values will be between 1 and max of piles. And why is that? The reason is she will at least we can choose basically k equals to 1 would be the minimum eating speed that we can choose, and I know in this case she wouldn't be able to finish all the bananas, and we'll understand why. But maximum bananas, we would want the rate that we want her to eat every hour would be maximum from the piles, because why would you want any value bigger than the maximum from piles? Because if we choose maximum from the pile, then she can finish all the bananas on that pile in 1 hour, right? If we choose this speed. So those values are going to be between, the k value is going to be between 1 and maximum max from the pile. So brute force approach, by the way, brute force approach would be just going one by one from 1 to max piles, and checking if we will be able to finish all the bananas, and still be within this hour range. So if we choose k as 1, then we want to basically have our hours, basically this hour variable, let's call it hours. So we're choosing the eating speed as 1. So what's going to happen is this is where we're going to take 3 hours to finish this entire pile, and then here we will basically take so remaining this. Now we have spent 3 hours eating the first pile. We move to the second pile and there are 6 bananas and our eating speed is 1. Then we can't finish all the bananas. There will be 1 banana left and we are out of hours. Guard's gonna come back, kick Coco's ass, kick her out, and she couldn't finish all the bananas. So what we're gonna do? We choose a bigger k, right? We choose a bigger k. What will be a bigger k? That will be 2. If you are doing a linear search, basically you're linearly choosing these values. So I'll choose k as 2. What's gonna happen? My eating speed is 2. Here it would be basically 3 divided by 2, 1 point something, but we know that we're gonna choose basically the upper bound since she does not switches to another pile, right? She's not gonna switch to another pile and whatever the time is left, she start eating those more bananas. No, she's gonna just be there, relax. Sorry. So this will be 2. So she spent 2 hours here, and then now 2 hours gone from 8. Basically now we have 6 hours left, and I think we don't have to write it down like this. We just understand, like, verbally. So we have now we come over here. 6 by 2 is 3 hours gone. So plus 3, now we have 5 hours are gone and remaining hours are basically 3, right? So 5 plus 3 is 8. Here we have basically remaining hours are 3. Can we finish all these 7 bananas in 3 hours? So 7 by 2 gives us 3.5. No, we cannot. We cannot finish all the bananas in if our eating speed is 2. So what do? We will basically choose a bigger k. And let me tell you, like, I don't want to go like one by one here. What really happens is when we get to k as 4, that's when we realize this pile we have just finished in 1 hour. This pile we have finished 6 by 4 in 2 hours. This pile we finished in 2 hours, and this pile we finished in 3 hours. So if you sum that up, it gives us 8. 2, 2, 4, 1, 5, and 3, 8. Now this is equal to our hours given when our guards will be back. So now we know we have a k that we can choose, which is 4. If we choose our eating speed as 4, then we know we will be able to finish all the bananas. Coco will be able to finish all the bananas. It's not us. We are not eating bananas. Coco is eating bananas. She will be able to finish all the bananas, all the piles in 8 hours. That should be our minimum eating speed. But right now we were trying to find that out just in a linear fashion, from going from 1 to basically, keep incrementing, because we want to find out that minimum eating speed so that we will be able to finish all the bananas if we choose that speed. Okay, so is there a better way? To find out that k? Yes, there is. How about, since we have this range from 1 to max pile, so in this case let's understand this on our example here. So since we have this range of for k, which will be from 1 to 1 2 3 4 5 6 7 8 9 10 and 11, right? This is our range for k values. That's gonna be from 1 to k. And what we were really doing right now is basically going from 1 to maximum k and stopping at 4, because that was the value where we were able to finish all the bananas within within h hours. How about we just maintain our we try to find that k using binary search. So what do we do in binary search? We have our left and right pointers, and then we try to find out the mid. So that will happen using basically I think, since it's the index, so it's gonna be left plus right, which will be 12 divided by 2, which will be 6. Can we choose k as 6 and be able to finish all the bananas in h hours? Yes, I think we can. But definitely we're gonna find that out using a for loop, by going basically this will take 1 hour, this will take 1 hour, this will take 2 hours, this will take 2 hours. So 2 to 4 5 and 6, and we have 8 hours, but we were able to finish that in way less hours. Like we were able to finish it in 6 hours. We still have 2 hours left. So really what's going to happen is we're going to try to basically minimize. We want to choose the minimum k, but this one works for us. This is not what we're going to return. So what we'll do is, since we will assign this to our result, we'll maintain some result, we will assign it to result, but move our right pointer to basically k minus 1, which will be 5, and then we find again our mid would be 3. This doesn't work, so left pointer goes to 4, and over here we find out the mid, which would be 4. 4 works, but at this time we will bring our right pointer to 3, left pointer goes left pointer remains there, but that's when this binary search while loop, the condition that we have becomes false, and that's when we come out of the loop and we return 4 as our answer. Okay, so we're gonna do binary search on these k values, and for each value as mid we choose, we calculate using that how many hours. If we choose that as our k, it's going to take us basically to it's going to the number of hours we're going to take if we choose k as eating speed. So that would be basically if we have these are the values that we're going to have. So max k, if I say max k is basically max from pile is p, then our time complexity would be big of log p, and for each of them we are basically from our pile we are basically calculating the number of hours. So that's gonna take, let's say if that is n, so that this will be our time complexity. But it is better than if we are going to do it this in a linear fashion. So p into n, this is definitely better than p into m. So if log p into n. Okay, so let's go to coding part and implement this solution. So what are we gonna do right now? Let's find out our range, left and right pointers. So left and right pointer would be, we're starting at 0, and then starting at 0. Actually, we're not starting at 0, we're starting at 1 in this case. And what's gonna be our last would be maximum from piles. Okay, maximum from piles. And while left is lesser than or equals to right, what we're gonna do is we're gonna choose this k. K will be left plus right divided by 2. That is our k. So let's find out the number of hours. Initially 0, and what I'm gonna do is let's have result, and for now let's just assign the result as basically maximum from the pile, because if we choose that, then that's the maximum value that we can choose, and it will always pass, right? Because we will be able to finish one pile in 1 hour. And even if there will be a lot of piles, and this might fail, but I think it will not fail. What I mean is there will be enough hours available so that if we finish each pile in 1 hour, then this should be basically less than the hours that are given to us. The length of piles should be less than the hours given to us. This is what I'm trying to say. But you can definitely ask that to your interviewer, but in this case I think it will pass. Okay, so what are we gonna do now? We have that hours assigned as 0, so we're gonna have this while loop, which will be basically for p in piles, and let's find that out. We're gonna add basically to our hours, and we're gonna do p divided by k, but we're gonna do math dot seal to basically choose the upper bound. Or is it not like, okay, I think I might be doing it wrong, so let's just search math.seal, python math.seal. So that's just choosing the upper bound. So math.seal, I think that works. Okay, I don't know, it should be showing as like different colors, that's why I was confused. Okay, so we keep doing that. Once we come out, if basically these hours that we just found out, how many hours it's going to take if we our eating speed is k, then if hours are basically smaller than or equal to the given h, that means this passes. This passes means result will be minimum of basically this k or result itself. Okay, and in this case what we want to do is, since this mid that we just found out, mid is k here by the way, then we want to try to find out the minimum basically. So we'll move our right pointer to basically k minus 1, right, k minus 1, else we will just basically move our left pointer to k plus 1, since we need to find a bigger k. Okay, otherwise we'll just return our result is our minimum k that was assigned to us over here. And what really must have happened is we were able to find a k that passes, that the number of hours it took us to finish all the bananas, that must have been lesser than the given number of hours here. So okay, let's try to zoom out and run this, and I really hope this passes the test cases. Yes, it does. So let's submit our answer, and voila, awesome. Okay, so let's write down the time complexity. Time complexity would be, so basically big of, by the way, this is where the binary search is taking place, and that is basically big of log. And if we say max of pile is basically p, so log p into, for each log p we are doing basically, we're going over each p. So I think we could say that as n is the length of all the number of piles in this array. Okay, so I think this is still fine. Usually people would like to call it p, and this something as max p or whatever. And then space complexity would be constant. We didn't use anything, but I always like to talk about it in binary search. Although usually we could be playing around with these pointers, bringing down our input size to half that we are doing over here for this p between 1 to max piles and we're just trying to choose that minimum k. Oh yeah, okay, so let's go back to AlgoYogi, mark this solved. I'll see you guys later in the next problem. Until then, bye bye.